Okay, so this is the square root of 12, x to the 6, y cubed. It's really three questions at once. The square root of 12 times the square root of x to the 6 times the square root of y cubed. Square root of 12 is, you break apart with a little factor tree here. 2 comes out, 2 square root 3. X to the 6th, this square root is really like a 1/2 power. So if the exponent divides evenly into the 1/2 or multiplies by 1/2 evenly, you just write that result. So like this becomes x cubed. This one is a little bit different. It's an odd power. So it's y squared and y. And the square root of y squared becomes y, but the square root of y just comes down with it. So then you pair up the parts that are outside and then the parts that are inside for your final answer. This is 2x cubed y, that's the outside part. Square root of 3y is the inside part on that.
Okay, that makes sense.
Number 2. Number 2. So cube roots are the same, but you're looking for triplets instead of pairs when you're trying to figure out what you can bring out. The other property here is that it becomes the cube root of the top divided by the cube root of the bottom.
Okay.
So we'll just look at these together. So this is really the cube root of 32 times the cube root of x to the 5th times the cube root of z squared. So 32 will break apart with a factor tree. And you're looking for a triplet. There's your triplet, three 2's, and then there's 2 2's left over, so those come, the triplet comes out, and then the 2 2's make 4 down here. Now this x to the 5th, if you look back in the previous problem, we broke y cubed into y squared times y. The x to the 5th is broken into powers of 3, so it's x cubed times x squared. And the x cubed is what brings the x out. So x on the outside, cube root of x squared on the inside.
Oh, okay.
Okay. This last one, a little bit of an exception. This power of 2 is not bigger than 3. So it's kind of like the cube root of x squared. You just leave it. This also just becomes the cube root of z squared. So if the power inside is smaller than this number on the outside, you just leave it for now. So then you pair up the stuff on the outside. So there's a 2x on the outside, cube root of whatever's left on the inside, 4x squared z squared for that.
Got it.
All right, number 3. All right, it says to multiply. This is a FOIL problem. So you got your 4 times 3, that's 12. Your 4 times minus 2 square root 5, that's minus 8 square root 5. You can only multiply the outside numbers like that. The inner is 3 times square root of 5, so that's plus 3 square root 5. There's really a 1 there, so if you have to match those up, it's with the outside. And then the last is square root 5 minus 2 square root 5, so it's minus 2 square root 25, because the inside numbers get multiplied also.
Oh.
That's all review, hopefully. And this last one becomes a number. The square root of 5 is 5. So this becomes minus 10. We'll just bring everything else down. You generally can combine like terms. So you can combine these two, and you combine these last two. So 12 minus 10 is 2. Minus 8 plus 3 is minus 5 square root 5.
Okay. Got it.
All right, so this one says to rationalize the denominator. This one's, I wouldn't think you would say this because it's kind of an advanced problem here. So you're trying to figure out, what do I multiply the denominator by so that it, like, this cube goes away? And you have to, it's kind of like a game, like you're trying to figure out, what should this go to? Well, if this is 125, the cube root of 125 is known, because that's 5 times 5 times 5. The 5 times 5 times 5 is 125. So you have to kind of know where you're going to be able to answer this. And then if you had an x cubed here, the cube root of 125 equals 5. The cube root of x cubed equals x. And that's what we need to get to. So, like, what do we multiply by to get that? Well, if you multiply by the cube root of 25, 25 times 5 gets to 125. X times x squared gets you to x cubed.
Oh.
So you have to know where you're going to figure out what to multiply by.
Okay.
All right. So then you do the same on the top, the cube root of 25x. So there's a lot of words that go into this, but the end result is that the top looks like 15 cube root 25x. The bottom looks like this over here. It's the cube root of 125. It gets 5 times 25, 125. X squared times x is x cubed. And then the bottom works out nicely. You get cube root of 125 is 5. The cube root of x cubed is x. And you just rewrite the top. Last thing that you can do is 15 and 5 go into each other, makes 3 cube root 25x over x. Is that okay? Is that
Yeah, I got it.
All right, so let's look at number 5 here. Do you know if you're going to be allowed to use a calculator, if it's going to be a calculator or not section?
I think at the beginning of the page, there's no calculator and calculator part for everything. So
Okay.
I think this is no calculator.
All right, yeah, this one's definitely no calculator if that's the case. So the base to a power, you have to rewrite the base. So you forget about the power for a moment. That'll come with it. It's like, how can I rewrite 32? So you're supposed to know, like, all these different exponents, like 2 squared is 4, and 3 to the third is 81, and there's a whole list of these that you might want to remember. But 32 is written as 2 to the 5th to the 3/5 power. So then when you have an exponent to an exponent, you multiply them. So what is 5 times 3/5? Well, the 5's cancel and you're just left with 3. So this whole part right here, this exponent to an exponent becomes 3. So this is 2 to the third, which is 8. Yeah. Especially if you had a calculator, because you can basically do it without that. Hang on just a second, please.
Okay.
All right, I'm back. So let's look at number 6.
Okay.
It says write answers in radical form. Okay. Okay, kind of, again, a lot going on here. This is one of those more advanced questions, like, I don't think you would see on a final, but we'll go through it. When it says right answer in radical form, they're expecting to have some sort of this symbol and maybe a number here when you're all done.
Okay.
But to do that, you have to convert it to exponent form and then back. Okay, so this right here, this piece is written as x to the 3/4 power.
Yeah, I remember this.
Okay, and then this one is written as 8x to the 1/3 power. But we can actually evaluate the cube root of 8. So the cube root of 8 equals 2. So we can actually just make a little bit better. This becomes 2x to the 1/3 power.
Okay.
Okay, and same thing down here. You have 81. You have the 1/2 power means the square root of 81. That equals 9. So on the bottom you have a 9, x to the 1/2.
Okay.
So that's 2/9. 2/9. Okay. And then you have 3/4 plus 1/3. So when you have bases are the same, you have to add the exponents. So it's x to the 3/4 plus 1/3 over x to the 1/2. So 3/4 plus 1/3 is 9/12 plus 4/12. So that's 13/12. And then you're dividing it by 1/2. So you end up subtracting the bottom exponent. So this is x to the 13/12. This is x to the 1/2. So your final answer, you have to subtract 13/12 minus 1/2, which is 6/12. So that's 7/12. You get x to the 7/12. But it says to write in radical form. So you have to know to write this as the 12th root of x to the 7th.
Oh, okay.
A lot there.
Yeah, that's just a lot going on, but
Wouldn't expect that on there, but maybe
yeah.
you can look back at your notes if you want to see that again.
Okay.
Okay, solve. Cube root 5x minus 1 equals 4. So first thing you're going to do is undo this cube root on the left. So you're going to cube both sides. So the cube on the left undoes the cube root. So the cube undoes the cube root undoes cube. You're left with just what's inside parentheses. 4 to the 3rd is 64. And now this is just solving multi-step equation. You add 1 to both sides. 5x equals 65. Divide both sides by 5. And then x equals 13.
Okay. Yeah, those are pretty easy.
Yeah. All right. Okay, so to solve this one, it's kind of the same idea, but you have to check for extraneous solutions when you're all done. You undo the square root with a square.
Oh yeah.
Okay, so the left side becomes x plus 5. The right side becomes x minus 1 times x minus 1. You write it this way so that you remember to FOIL, so you don't accidentally get a solution that's incorrect. So FOIL here, you get x squared minus x, so minus 2x plus 1, x plus 5. We're going to move everything to the right. So on the right here, you get x squared minus 3x minus 4. You factor this, x minus 4, x plus 1, and you get two solutions. You find that x is either 4 or x is minus 1, but they might be extraneous. We're not sure.
Oh.
So you're really supposed to check both. So that's where we're going to go back to the original. Okay, so the check here, let me just grab the original again, and we'll check it here. Okay, so you try 4. The square root of 4 plus 5, does that equal question mark 4 minus 1? Is the square root of 9 equal to 3? Yes. And then you do it again. Is the square root of negative 1 plus 5 equal to minus 1 minus 1? Is the square root of 4 equal to negative 2? Is 2 equal to 2? No. So you would have to somehow say here that x equals 4 is the only solution.
Okay. Got it.
Okay, so for 9 through 14, the same equations are given. So let me snip that in. So for number 9, it says to add. It says f plus g of x. F plus g of x. That just means to add them. So that's x squared minus 5 plus 2x plus 3. Only two things you can combine here. We have x squared plus 2x minus 2. You're done.
Mhm.
Number 10 is a different, let's see if I can get this snipped in here again. Number 10 is to find f g bubble f. G bubble f of 3. This is composition. Okay, so this means the same as g of f of 3. So there's steps here. The first thing you do is you find f of 3. So that's 3 squared minus 5. That's up here. That's 9 minus 5. That's 4. So you find the inside part first. The second is you take the output, which is 4, and you find g of 4 now. Like whatever that number is goes in there for the other one. So that's using the second equation. 2 times 4 plus 3, which is 11.
Okay.
And you get to do it again. Nope, you get to go the other way. So now number 11 is f bubble g of x. So again, same thing as you find g of x. Well, g of x is given. That's 2x plus 3. So the second thing is you take the output, which in this case is 2x plus 3. That's the output. And you put that into f of 2x plus 3. So this thing goes right in there. So f of x is x squared minus 5. A lot of words to say you're taking this and you're putting it there. So f of 2x plus 3 equals 2x plus 3 squared minus 5.
Yeah.
Okay, so a lot of words. You're going to FOIL here again. Do not just square the first and the last. It's 2x plus 3 times 2x plus 3 minus 5. So that is 4x squared plus 6x plus 6x plus 9 minus 5 becomes 4x squared plus 12x plus 4.
Can you just leave it at that?
Yes.
Okay.
Yep. Okay. Yeah, so let's move to 12. 12 is 12 is g of f of x. So this is the same as g bubble f of x, but this is how it was written on your practice thing. So I didn't snip this in, but it's the same equations. So you're taking f of x, which is x squared minus 5, and you're putting that into there for g of x. You take the inside and put it into the outside. So it's 2 times x squared minus 5 plus 3, because that's the 2x plus 3, and that's your new x. You distribute in 2x squared minus 10 plus 3. So you have 2x squared minus 7 for that.
Okay.
All right, we're up to 13. So 13 asks for g inverse of x. Well, g of x equals 2x plus 3. So to find an inverse, there's a recipe. The first thing you do is you write y equals 2x plus 3. So this is step 1. You do a y equals. Step 2 is you switch x and y. So wherever you see an x, you put a y. Wherever you see a y, you put an x. And then step 3 is you solve for y. Solve for y here. So that's where most of the work is. You can subtract 3 from both sides. Divide by 2, divide by 2. So you have y equals x minus 3 divided by 2. And that is your inverse. So it's not really a step, but you could write it that way. Step 4 is that y equals g inverse of x. Basically, you're just writing g inverse of x equals x minus 3 of 2. It's a notational step.
Oh, okay. That makes sense.
So you're done here, but you know, sometimes they want you to do a little bit more. All right, so 14, we're not going to do because it's just a property. G inverse of g of x equals x. G of g inverse of x equals x.
Okay.
So whatever that number is, you get it out.
Yeah.
So 14 is, the answer is minus 43.875.
Okay.
All right. Do we think 15 is covered? So we're at a point where if we don't move on to another exam, we're not going to get through all of them.
Yeah. Let's just move on then.
Okay.
Yeah.
Let me look for chapter 7. Okay. And I'll just do the same thing with this one. All right, so we're up to chapter. All right, identify each function as growth or decay. So the answer depends on the value of a. A is this number in parentheses. It's kind of this number in parentheses here. Okay, so here a is greater than 1, so it's growth.
Mm-hmm.
That's kind of the simple answer is greater than 1 is growth. If a is between 0 and 1, it's decay. And that's why this one's a little bit deceptive. This negative actually goes with this thing here. So this is really 1 over 1.05 to the power of x, because you can just apply the negative to that.
It's decay.
Yeah, so a is between 0 and 1, so this is decay. And then this is decay because it's going down and to the right. Growth, well, let me draw over it. Growth goes up and to the right.
Okay.
All right, number 2. All right, given this graph, 2 to the minus x minus 3 would yield its graph. So let's start with y equals 2 to the x. That is a growth function.
Yeah.
We just mentioned this before. This negative really goes with the exponent, really goes with this. This is 1 over 2 to the power of x minus 3. So this number is now between 0 and 1. So this is actually a decay. Like, it doesn't ask for that, but that's just another sort of example of this. So the transformations, there's 2 things that are going on here. It's this negative x, which we now know that it means decay. And then there's this minus 3, which is a vertical shift down 3. So there's actually only 1 decay. So, I mean, it's kind of silly that it's asking for that, but actually, I guess this is decay over here, but this is growth. So, and that's down 3. If you have a calculator, which we're not sure, you probably don't get one here, but you would want to graph that. The domain for all exponentials is always all numbers.
Okay.
It's always all numbers. The range is two options. It's either minus infinity to the horizontal asymptote, or it's the horizontal asymptote to infinity. And it depends. It depends on whether it's going up or going down. So based on this graph here, you probably tell that the horizontal asymptote is at -3, and it goes up from there to infinity.
Yeah.
All right, page 2. A couple questions here. All right, so we got 3 and 4. So the one on the right here, I'm gonna do first. 4 to the 1/2 power equals 2. So you have to say, okay, how did I map these things? Well, the 2 came over here, the 1/2 came there, and this 4 kind of came there.
Mm-hmm.
So the number 3 is like going backwards. Are you able to? Um, can you try that one?
Yeah, I think I can.
So give that a try. Let's see how you do on that. I'm going to just check something real quick
Okay.
before we move on to something else. All right, so did you come up with something like log base 10 of 10,000 equals 4?
Yeah, that's what I got.
Great. Okay. Would expect you'll see something like that on there, but of course, I never know. All right, number 5 here. So it says evaluate these. If you had a calculator, these would be real quick to do. With logs, you really want to write this part, which is the thing you're taking the log of, as a base to a power, but you want the base to match whatever's down there. So essentially, I'm asking you to say, well, can you write 125 as 5 to some power? And you can. It's 5 to the power of 3.
No. Is that all you have to do? Just like break it down
Yeah,
for
there's a little bit
that?
more. I mean, you have to move this out in front. These are the steps, but you don't have to necessarily show them all.
No,
Whenever you
yeah.
have log base b of b, this equals 1. So this is 3 times 1.
So I'm just supposed to put it in logarithmic form?
You're supposed to get a number.
Okay.
So you make this change up here. 125 is 5 to the power of 3. You bring the 3 out in front. Then you recognize that log base 5 of 5, or log base b of any of the same number, is always 1. So this part becomes 1. 3 times 1 is 1.
Oh, okay. That makes sense.
Okay, so same thing over here. A little bit more difficult because it's a 1 over. We'll deal with that in a moment. What is 16 as 2 to some number? Do you know that?
Um, 2 to the 4th?
2 to the 4th. Okay, so now 1 over 16 just means you're going to negate this exponent, so it's 2 to the negative 4.
Okay.
Okay, so 1 over 16 becomes 2 to the minus 4. Same deal again. You move that negative 4 out in front. Log base 2 of 2. This becomes 1. It's negative 4 times 1, which is negative 4.
Okay.
right, so 6 and 7 are very much related. One is the forwards, one is the backwards. You'll be expected to expand and then compress or condense logarithms. So there's a lot of properties going on here. One property is and I'll do these one at a time. So if you have log of a over b, this equals log a minus log b. So
Okay.
it's log 2x square root y minus log z cubed. So it's top minus bottom. The next property we're going to use is the log of a times b times c equals log a plus log b plus log c. So like 2 is your a, b is your x, and square root of y is your c. So it becomes log 2 plus log x plus log square root of y minus log z cubed.
Okay.
We're not quite done. I'm going to rewrite this y as y to the 1/2 power. So last property, log base b of x to the n equals n times log base b of x. In other words, you take this exponent, and you have 2 of them here, and you move them out in front. So this n is your exponent, it comes out in front. So the ones that don't have it, you don't make any changes, but log of y to the 1/2 becomes 1/2 log y minus 3 log z.
Okay. Um, all right. Can we go down to number 9?
Yes. All right, number 9, part A. The game here is to get both of the bases the same. So like 16 is 4 squared, but 8 is 2 cubed.
Mm-hmm.
So can you make 16 into 2 to some power? Can you make 8 into 4 to some power? And the answer is 16 is 2 to the 4th, and 8 is 2 cubed.
Uh-huh.
Okay, so that's how you arrange them with the same basis. When you have an exponent to an exponent, which is what we have here, and we had in a previous problem, you multiply. So this is 2, 4 times x minus 1 equals 2, 3 times x plus 2. So that's 4x minus 1, and that's 3x plus 6. Since the bases are the same, you set the exponents equal. So you said 4x minus 1 equal to 3x plus 6, and then you solve for x. So move the 3x over, add 1, you get x equals 7.
Okay. That makes sense.
Part B is not really related, not sure why it's here. You're undoing log. Like this whole chapter is you're solving exponential equations, or you're graphing exponential equations, or you're doing some of the exponential equations. Then you're doing all the same things with logarithmic equations, and they're really they're really two streams. There's everything you do with exponents and everything you do with logs, and there's sort of like, oh, some things work here and some things crisscross, but you have to really have a mindset for each. So here you have to undo base 3. That's that one right there. So to do that, you write 3 to the log base 3 of 2x minus 3 equals 3 to the power of 2. So this bases are the same. And that's what's meant by undoing it here. So when you undo it, it gets rid of it. It's like squaring a square root. You're just left with 2x minus 3 equals 9. And from here you solve. So you add 3, 2x equals 12, and x equals 6.
Got it. Um, All right, he said these word problems weren't going to be on there, so we don't need to do those. Can we do one with natural log? Maybe 12D would be good, and then we
Yep.
can finish up on this one.
Okay. So you'll notice in this previous problem, the log was already solved for. It was already by itself. Here in D, you have to get the log. You're going to make this into, you really want one log here, or one ln, if you will. So you have to combine these. So it's kind of like a problem where you have to condense, which we didn't do. This 3 can come up here as an exponent. So this becomes the natural log of x cubed minus the natural log of 2 equals 4. And then there's that property that the natural log of a minus the natural log of b equals the natural log of a over b. So on the left, this becomes natural log x cubed over 2 equals 4. And now you have to undo ln, which you do with e.
Okay.
So you write e ln x cubed over 2 equals e to the 4th. The bases have to be the same. That's what we did here. By undoing ln, it just becomes x cubed over 2 equals e to the 4th. And now you're just solving for x. So you're multiplying by 2. So you have x cubed equals 2 e to the 4th. And then you undo cube with a cube root. So you have x equals the cube root of 2e to the 4th.
Okay, yeah, got it. All right, now we can move on to chapter 8.
Okay. What question on, where do you want to start with 8 beginning?
Can we just do 1A? I don't remember how to write the inverse equation thing.
Yeah. Okay, so the inverse variation equation it's generally written like this: y equals k over x. But here you have other variables, but the inverse part is the fact that it's in this form. I'll just write off to the side: direct variation is y equals kx. So you might see that as well in a different problem. Okay, p and v are inversely related. Okay, so that means that p equals k over v.
Yes.
So they're going to give you p and v, which they give you here. They tell you that p is 3 and v is 24, and you have to solve for k. So k equals 3 times 24, which is 72. And then you rewrite this with the new k. So p equals 72 over v. And that's your final answer for that.
Okay.
So then in part B, you are changing. You're using this equation. Like they tell you that the pressure is 8. They want to know what the volume is. So they give you one variable to find the other. So in part B, they tell you that the pressure is 8, and they want you to know, well, what is V? So 8 equals 72 over V. And then if you cross multiply here to do that, you get 8V equals 72. V equals 72 over 8, which is 9.
Okay. All right. And then we could either do 2 or 3. They're the same setup.
Okay. Are you asking me to choose?
I don't know. Which one's like more difficult?
I think 3 is slightly.
You got that.
They have a lot of the same stuff on them, but okay. Number 3. All right, so the vertical asymptotes, great. You would think, oh, I can start right away, but the first thing you want to do is you actually want to factor the top and the bottom and see if anything cancels.
Oh,
So like the top becomes 2 times x minus 1. The bottom is x minus 2, x plus 2. There's nothing that cancels, but if it did cancel, there would be a hole there. But you factor it first. It also helps you answering some of the questions. So vertical asymptotes,
uh-huh.
they're where the bottom equals 0. So where does you're looking where x squared minus 4 equals 0. We already factored that, so we're going to want to look at it in this form. So you'll find it's at x equals 2, x equals negative 2.
Yeah.
The horizontal asymptote, well, that comes from setting the under if there well if there was a number being added outside here, it would have an impact. Here, it's based on the degree of the numerator and the denominator. So
Okay.
since the degree of the numerator equals 1, that's the exponent, and the degree of the denominator equals 2, since 1 is less than 2, this becomes y equals 0.
Got it.
But like in question 2, which I guess we can't get away from, excuse me, the horizontal asymptote is at negative 1 because there's a negative 1 off to the
Yeah.
side. Okay. All right,
Uh-huh.
y-intercept, that means that x equals 0. So you're literally finding f of 0, 2 times 0 minus 2 over 0 squared minus 4. Minus 2 over minus 4 is 1 half. Sometimes you write that as an ordered pair, so it would be 0 comma 1 half. So the key thing here is not these answers. It's like, oh, when I find the y-intercept, I'm putting that 0 in for x. The x-intercept is setting the numerator equal to 0.
Yeah.
Okay, so that means setting 2x minus 2 equal to 0. Solve for x, x equals 1. If you want to write that as an ordered pair, it's 1 comma 0. So we have enough to graph this, I think, which is what part F is doing. But sometimes it's better to draw your graph and then just match it. So we know, for example, that it has a vertical asymptote at 2 and minus 2. We know that it has a horizontal asymptote at 0. We know that it goes to the x-axis there and there. And that's probably enough to figure out the answer here.
Yeah.
For this one. Let's see here. So this one has to snake because it goes through there. And then there's only one that looks like that, and that's graph B.
Mm-hmm.
If you can graph these, you can answer a lot of these questions. Like if Desmos is available to you on this, you can just plug that in, look at the graph and answer the questions, but you don't show any work. So that's it's up to you.
Yeah.
Okay, where should we go from here?
Okay. Maybe number 6. The rest of it is just like the complex fractions.
Yes. 6 is a for sure a factoring.
Yeah.
Got to be really good with your factoring. Greatest common factors, difference of squares, all kinds of stuff. Factoring type A equals 1. It's just a lot here, and so you generally factor and then you have to rewrite here, and a lot of stuff's going to cancel. So the bottom one here is difference of squares. I've already written that down here. The division becomes multiplication by the reciprocal. So it's really like, and if you need to, you can rewrite it, but this goes up top and this goes on the bottom. So we need to factor x squared plus 6x plus 9, and then 6x cubed plus 18x. A technique I like is to actually write it above or below it. So the top is x plus 3 times x plus 3. Okay, and the bottom here is 6x, x squared plus 9. I'm sorry, plus 3. Okay, so like what I see here, x plus 3 cancels with x plus 3. One of these x's cancels with one of these, so that means there's 2 x squareds there. Actually, we should cross that out as well. 2 and 3. When you do a lot of crossing out, it's easy to miss things. So this is 2x squared times x plus 3 over, we got x minus 3 from the left here. And then this, see, I almost did that. There's a 3 that comes down, and x squared plus 3 here.
Okay.
So there could be, like, sometimes these even reduced to just a number. You just got to be on the lookout for that as well.
Yeah.
Okay. We got time for one more if you'd like, or we take a break. It's up to you. Just let me know where you want us to go from here.
Okay, let's just do 11 and then we'll
Okay.
take a break and then start on a new chapter.
Great. All right, so 11 is this question there's a bit of a shortcut, but it always works in these time problems or these work problems where, you're doing something, they're doing something, and then there's the together. So there's 1 over time 1 plus 1 over time 2 equals 1 over together. So in this case, if you do it by yourself, it's 5 hours. And if a friend helps, you can get the same room painted in 2 hours. So that's the time together.
Okay.
So that's the together time. That's the both, whatever you like, the group, whatever. So you're just solving this. You're just solving this equation. It looks maybe more complicated than it is. If you were to write these as decimals, you would say, I can solve this because it's 1 over t equals 0.3. And then if you back out of decimals and just go back to a fraction, you can cross multiply. So this becomes 10 equals 3t. So t equals 10 thirds. And that's 3.33 hours to do it on your own.
Okay.
Okay, so we will stop here. Please use the second booking email for the link to connected lesson. And I'll send you the notes and the screen recording out a little later today.
Okay, I'll see you in 10 minutes.
See you in 10 minutes. Thanks you. Bye now.
Bye.